In this video, I am going to walk you through how to do the calculations for the hydration of a salt lab. Once again, you will have 3 trials and a data table given to you with pictures of the empty beakers for all 3 trials. Note that in this lab, you will have 3 different beaker masses, so click on all 3 of them to be able to get the mass for all 3 trials. And then you will have pictures for mass of beaker plus the hydrated copper sulfate. This will be the blue colored crystals, and the masses will go here. And then lastly, the mass of beaker then and anhydrous copper 2 sulfate, and it will look like a white powder. And you will put that in all these 3. Now let's look at the calculations. First question, calculate the mass of anhydrous copper 2 sulfate in each beaker. So you will take the mass of the dried minus the mass of the beaker, and this will give you the mass of just the anhydrous copper 2 sulfate. The next question asks you to calculate the moles of the anhydrous copper 2 sulfate, where you're going to take the mass that you found from part 1 and you divide that by the molar mass of copper 2 sulfate. So part 1 divided by the molar mass of copper 2 sulfate. Obviously you'll have 3 calculations, just show one in detail and then the other 2 just give the answer. Then in part 3, calculate the average number of moles of copper 2 sulfate, so average the answers in part 2. Then you're asked to calculate the mass of the water that is lost from each beaker. You'll take the mass of the hydrated copper 2 sulfate and you subtract the mass of the anhydrous. So this is with the water and this is without the water. So if you take the difference of those 2, will give you the mass of the water that was lost during heating. Then you calculate the moles of the water that are released by taking the mass from part 4. This is supposed to be 4, 5, and 6. It somehow didn't translate. But you take the masses of the water that you found in part 4 and you divide by the molar mass of water to get the moles. Then lastly, you calculate the average moles of water just like you did for the copper 2 sulfate. The last part, so part 7, you take the moles of water from part 6 and you divide them by the average moles of copper 2 sulfate that you found in part 3. So the average moles of water divided by the average moles of copper 2 sulfate, convert it to a whole number ratio. So round it to the closest number, and then that will go here and here as well. So however many molecules of water are attached to copper 2 sulfate, hopefully that is what is released at the end. So after the heating occurs, that water is being released. And hopefully just the water, and we're not breaking this down. Okay, those are the calculations for this lab.